Let's look at a little bit of a different logic problem, a little bit more complex. I've got some code here to start out with. Let me just show you what this ends up generating. I've got it in a file called grid.html. So this just generates a 5 by 5 grid using some flexbox here. And these just have random, random values, anything between 0 and 4. So let's take a look and see, first of all, how that is generated, and then we'll talk about the logic. So here, I'm generating a two-dimensional array. I'm setting up a value for my rows, and I'm looping 5 times for each row. I generate a row, I push this into the rows array, and then for each row, again, I'm looping with another index from 0 to 5, and I'm just generating a random number. So math.random times 4, and then I'm using the math object's round to round that up so I have an integer. So that gives me these rows. And we could actually take a look at that here. Let me just open this up. So these are our rows, right? We've got an array of length 5, and within each array, I've got another array with 5 random numbers. So the way that the HTML ends up getting generated is, again, by doing some looping. I end up looping over my rows. I'm using the map function, and for each row, I've got this string. So I've got a row that's here, and within each row, I'm mapping over the row for my digits. So I've got this HTML that's got an outer div of row. Within that, I'm going to have as many cells that I have in the row, and these have a digit, so I'm outputting the digit. And again, we could see what that looks like just by going over here and console logging the HTML. And we'll see here's the HTML that this ends up generating. And I've got my grid here that I'm selecting with a query selector. I'm setting the HTML. And the other thing that I'm doing here is I have a target on here. So if I click on any of the cells, I could see the cell that I'm clicking on. And you can take a little look. There's a little bit of flexbox here, specifying that I want my row to display as a flex, and basically that takes the row and displays it horizontally. And then for each of my cells, I want them to take up as much room as possible. So I give them a flex of 1, setting some border, setting a height. I also want to display the content in there as centered. And the other thing here is that I want to give an indication to the user that this is clickable. So I set the cursor as a pointer. So that's the basic setup for this. And the logic that we're going to look at is that let's say that we're concerned about what are the values around a cell. What if I wanted to find out, hey, look, what are my neighbors' values if I added them all up together? And so, we'll see that not every cell has the same number of neighbors, right? If you're, not on an edge, you're going to have 8 neighbors. But depending on where you are, if you're in a corner, you're going to have, 3 neighbors. You could see if you're on an edge over here, you're going to end up having 5 neighbors. So let's break down the logic of how we could, A, find all our neighbors, and B, how we can then end up adding up the values. And we'll stay in the middle of this at the beginning, and then we'll think about the edge cases, how we deal with that. So the first thing that I'm going to do is find out where I am when I end up getting clicked on. What are my coordinates? And the easiest way to do this is to deal with the fact that we have a tree structure here. And so I'm going to go over here and I'm going to say I'm the cell. Event.target, that's who I am. And I could console log this out. I'll see the same thing that I had before. But I could move up one level and say my row is the cell.parent node. And I could go over here and I could see my row by going over here, and this is the entire row. So I could click over here and see the row that I ended up clicking on. On top of that, I could say even though I have this already, I could still go over here and say the grid is the row dot parent node. And if I console log that, and I click on this, I'm looking now at the entire grid. And the reason why I'm going to do that, there are two values that I want. I want to get the cell index, so I'm going to create a variable called cdx for cell index. So what's the cell index? Well, I'm going to look at the row, and I'm going to look at the children of the row. Right, that's the row that I'm in. And I'm going to splat this out so I could use the index of. And I want to find the index of me. That's going to be the cell index. So this should be a 0, right? This should be a 1. This is where I am inside of the row. And if I want to find out where the row is inside of the table, it's similar. Here, I'm going to take the grid, and I'm going to look at the grid's children. Index of where is the row. And if I console.log rdx, I should see that this is going to be 0, this is going to be 1, right? This is going to be 2, the third row, fourth row, fifth row. Again, with JavaScript, things are 0 index. So the first step of this process is to find out where I am in the coordinate system. And if I know where I am in the coordinate system, I can determine where my neighbors are in the coordinate system. So in order to do this, we really have to think, as a grid. And again, let's start off sort of in the center of the grid. We'll work on the edge cases, which are actually on the edges, a little bit later. So if we know what our coordinates are, and we know what our row index is and our cell index, then what we need to do is we need to move to the row above us. That's going to have an index less than 1 from what we are. And if we look at, if we're talking about this cell that has 0 in it, this is going to have a row index which is 1 less than us. Same column index because it's right above us. Again, row index 1 less than us, but a column index which is 1 greater. And again, if we look at this, our neighbors here, same row, cell index 1 less, cell index 1 greater. If we move down, it's really the same thing as the top, except the row index is 1 higher, right? This is going to have a row index 1 greater than us, cell index of 1 less, same cell index, row index 1 greater, cell index 1 greater than us, and a row index 1 greater than us. So we could end up writing this out. And I find the easiest way to do this is to create an array. I'm going to call this points. These are really our neighbors' points, and this is going to be an array. And again, let's think sort of happy path that, we've got 8 neighbors above us. Let's start with the row that's above us. We're going to have a row index, whatever our index is, -1, because it's above us. And the column that's to our left is going to be cell index, -1. This would be to our top left. If we wanted to go right above us, we're going to have the same cell index. If we want to go to our top right, we're going to have a cell index +1. So this would take care of the indexes in the row above us. If we want to deal with our row, and again, we're not dealing with ourselves, we're just dealing with our neighbors, we would have the same row index as us, but we want to go to our left, so our cell index is going to be -1. And we don't want to count ourselves, so we're going to go to our right, cell index +1. And then if we want to go to the row below us, we're going to have a row index +1 because it's below us. And we want to go to the cell to our left, cell index -1. And again, we could copy and paste this from the top and just change the row index, but we could also just think about it. Here, same row, but directly below us, going to have the same cell index. And then if we want to go to our bottom right, we're going to have a cell index +1. So this is the coordinates of all the points around us. And we could console log these points just to see what they are. So we're going to have these 8 points, and we could look and see where they are in the coordinate system. Again, we could if we end up clicking on, something like this, right, we could see we're looking at, the top row and then some cells and then our row and then some cells and then the row below us and some cells. So to some degree, that's really the hard part of this exercise. You really have to sort of think about what the indexes are. And again, you're just creating a square around your index. So the first step is finding your index and then finding all the indexes of your neighbors. And again, we're going to think happy path here for a moment. We won't end up looking at the edges. And what I'm going to do here, I always tell you guys to start with a const. So I'm going to do that here as well, although I'm going to have to change it. And I'm going to say total. And what I'm going to end up doing, and we could do this with a reduce, but let's just keep it simple here for a moment. What we're going to do is we're going to loop over our points, and we're going to get a point. And within this, what I'm going to do is create another variable just so I could look at this. So here, again, I'm going to use this again. I'll say I have a point. The R index for the point is going to be the first value, and the column index, right, because these were my row index, these are my column index, is going to be 0.1. And I could console log this out, rdx, cdx, just so I could see it, make sure I don't have any errors at least, and again, stay here to the middle. So these would represent all the points around me, or the coordinates of them. And now what I could end up doing here is I could take my total, and in order to find my values, don't forget I've got my rows up here which contain all my values based on this coordinate system. So I could go over here and I could say rows rdx, and don't forget a row is made up of columns, and I could say cdx, each of those has a value, and I could do plus equals to add it up to see what the total is. And if I end up doing that, I'm going to run into a little bit of a problem. Again, I'm going to stay in the center, but here I'll say, hey, look, you can't modify a constant variable, and that's true, and that's why this total has to be a let. And what we should find out if we look around these values, so here I've got a 0 in the center. I don't really care what's in the center, but if I look around here, I'll see 3. I'm doing math on the fly, so I'm awful at it. 5, 6, 7, 10, 14, should be 15, which is what I end up getting. We could look at some other values as well, but again, it's going to just loop around these values. Now, I'm going to run into a problem here because I don't have any row below me. I don't have any columns over here to the right. So I'm going to run into errors where I'm trying to read properties of rows that don't exist. So all I need to do to solve this problem is that before I go in here and I try to access this, I really need to ask two questions. If there is, first of all, a row's value at this rdx, and if there's a rows.rdx cdx. So not only do I have to see, hey, look, is there a row here, but also, is there a value there as well? Do I have a row at this position? Because again, if I looped around here, I started over here, I'm computing values for a row that doesn't exist. Here I'm computing values for, to the right, even though I have a row, for columns that don't end up existing. And this should now end up solving that problem. This is a little bit easier math to do, right? Because this should be 5 and 3, which is going to be 8. This should be 7 and 3, which is going to be 10. And that really is going to end up taking care of the edge cases. So, you know, a fairly complex problem, but if you break it down into pieces, find out where I am in the grid, find out the points that surround me, total up those points, but also take into account that, hey, look, some of these points might end up being off the grid, and I need to adjust for that.